Why doesn't UV filtering prevent fading? Many people believe that it should, and 97% or better UV filtering, glass or acrylic, does provide the best protection available for framing, but it's not perfect protection. It can't completely stop the damage, which is not only fading and color shift, but also discoloration and deterioration of fibrous materials such as paper, fabric, leather, and wood. Ultraviolet is invisible and most destructive, but visible light is also harmful, and in the same way as ultraviolet, it's all radiation damage. Here's how that works. Visible light and invisible ultraviolet come in waves of radiation in different lengths. Wavelength is measured in nanometers. A nanometer is 1/1,000,000th of a millimeter. As wavelength increases, its energy decreases. So the shorter the wavelength, the more powerful the radiation. That is, 300 nanometer radiation is twice as powerful as 600 nanometer radiation. This chart shows the range of radiation that includes visible light and invisible ultraviolet. Remember Roy G. Biv from art class? Red, orange, yellow, green, blue, indigo, and violet? Those are the 7 primary colors of visible light, going from red at 700 nanometers to violet at 400 nanometers. Then we have a transition range of 20 nanometers, where visibility of the radiation diminishes as it goes from visible violet to invisible ultraviolet. The wavelengths for invisible ultraviolet range from 380 to 280 nanometers. Since these shorter wavelengths are more destructive and invisible, we want to block as much of that radiation as possible, and it will never be missed. On the other hand, the visible radiation that we call light, red, orange, yellow, green, blue, indigo, and violet, is what carries colors and images to our eyes. We want to transmit as much of that visible radiation as possible. Notice the black line going across the top of the chart? This line shows approximately the percentage of light transmitted through the glass or acrylic as indicated on the scale going up the left side of the chart from 0 to 100% transmission. Trace the line from left to right and you'll notice it takes a steep drop to the bottom of the chart through the transition range, where visible light fades into invisible ultraviolet. It is possible to block everything up to 400 nanometers, but that would also block part of the visible violet in the transition range. Here are some things to remember. All radiation exposure is harmful. If you reduce the exposure, you reduce the harm. The invisible ultraviolet has greater energy than visible light. It's more destructive because the wavelengths are shorter. Radiation damage, whether it's caused by invisible ultraviolet or the visible radiation that we call light, is cumulative and irreversible. And when the image is gone, it's gone. Damage increases with the intensity of the radiation and the duration of exposure. Sunlight is the most intense radiation on Earth. In an office with good lighting, you might measure 100-foot candles on a desktop. But outside on a sunny day, you might measure 10,000-foot candles on the sidewalk. So, if you're an artist displaying your prints and watercolors at an outdoor arts festival, remember that just a day or two of sunlight exposure might cause as much damage as months or even years of exposure to the relatively low intensity of artificial light indoors. For preservation framing, or if you just want to get the longest life out of a cheap print, use 97% or better UV filtering glass or acrylic. That's the recommendation of the Image Permanence Institute and the ISO standard 18902 for imaging materials, albums, framing, and storage materials. For glazing and picture framing, that's the preservation standard. You can look it up. Fading, color shift, discoloration, and other deterioration of artwork could have other causes too. Chemical reactions inside the closed-up environment of a picture frame, Environmental conditions, such as temperature and humidity variations, or airborne contaminants, pollution, can cause damage that could be mistaken for radiation damage. Now you know there's more to fading than ultraviolet, but 97% or better UV filtering is still the best protection we can get in picture framing.